Okay, so part one of this lab is comparing the soda straw to the coffee stirrer, and they're both the same length. And the soda straw is easier to blow through because it has a greater flow rate of air passing through it, while the coffee stirrer is harder because it has greater resistance to air. And part B of the lab is comparing five coffee stirrers bunched up to one soda straw. And so there's not that much difference, I don't think. I still think that the air through the soda straw was a little easier, but not by much to blow through. But compared to parallel circuit, the combined coffee stirrers can be compared to the parallel combination of bulbs because there are multiple paths for the air to travel down. If you remove one or two of the coffee stirrers and blow through it, it becomes more difficult to blow air through the bunch straws with less straws because a decrease in resistors of a parallel circuit, decrease in resistors increases resistance. So an increases in branches would lead to a decreased resistance in a parallel combination of bulbs because the charges can flow at an increased rate through more pathways. So for part C, if you put two together to make one longer straw, it's easier to it's easier to blow through a single straw because length affects the resistance of the wire. The greater the length, the greater the resistance. And with a series combination, as more bulbs are added, the resistance increases as well, since adding more bulbs would inhibit the flow of charge. And according to the equation of the resistance of a resistor, since based on the equation, it was important to have the straws cut to the same length in procedure A because since length affects resistance, it is important to have the length of the straws constant in order to accurately compare the effect area had on the resistance in part A. And based on the equation, the relationship between length and resistance is directly proportional. This is verified in procedure C because as the length of the straws increased, so did air resistance. And based on the equation in question 6, the relationship between cross-sectional area and resistance is inversely proportional, which is also verified in procedure A as an increase in cross-sectional area with a wider straw led to less air resistance. And the material for the substance that the current is flowing through is the same for both. Both use plastic. And in conclusion, this lab simulated both parallel and series circuits using straws and air. The straws were the resistors, while the air traveling through represented the flow of charge. In conclusion, a direct relationship between length and resistance was established with the observations in the formula, while an inversely proportional relationship between cross-sectional area and resistance was also established. An increase in resistors, which meant an increase in straws, led to less resistance in a parallel circuit, while a decrease in length and resistors, which meant less straws, led to a decrease in resistance in a series circuit.